Good morning, students. We are on lecture 5 of triangles. We were doing exercise 6.3. So, in our previous class, we have done up to question number 1, part 6. Today, we are going to continue from here. Our first question is question number 2. So, there is a figure given. Okay. So, they have said that find angle DOC, angle DCO. Okay. And angle OAB. What is given? That they are similar triangles. Okay. ODC and OAB are similar triangles. So as you can see, since this is 125, so angle DOC will be 180 minus 125. Why? Because this is a straight line. So this is a straight angle. So whole angle is 180 degree. So this angle will be 180 minus 125. So 55 degree. So angle DOC you have found. Right? So clearly angle DCO will be 180 minus sum of the other angles. That means 70 plus 55. Clear? So 180 minus 125. So again 55 degree. Now as they are similar triangles, therefore what we have? Angle DCO will be equal to angle OAB. Clear? Since DCO 55 degree, therefore OAB also 55 degree. So that's our answer. Okay, students. So all of the angles are 55 degree. Clear? Let us move on to our next question. Question number 3 says diagonal AC and BD of a trapezium ABCD with AB parallel DC. So there is a trapezium ABCD in which AB parallel CD intersect each other. So diagonals AC and BD intersect each other at point O. This is O. Using similarity criterion for two triangles so that OA by OC is equals to OB by OD. Okay. This one is very easy. You know why? As you can see, AO and OC belongs to triangle ACD, and OBOD triangle belongs to triangle ABD. Okay. So that means OA by OB is equal to OC by OD. This is you need to solve. So this becomes very easy. As you can see, we can rearrange this to become AO by OB is equals to OC by OD. Just interchange this one. So in fact, AO and AOB belongs to triangle AOB and OCOD belongs to triangle COD. So if we can prove that AOB is similar triangle COD, then by using similarity criterion, this will come. So let us prove. How do you prove? So from triangle AOB and triangle COD, what can we have? Number one, we have angle CDO is equals to angle OBA. Why? Because they are alternative interior angle as AB parallel CD given. So see Z, so CDO is equals to OBA. Okay. Number two, we have angle DCO is equals to angle OAB. Again, they are alternative interior angle. And number three, we have angle DOC is equals to angle AOB. Why? Vertically opposite angle. So therefore, by angle criterion, they are similar. Say AOB, similar triangle COD, angle similarity. Clear? So since they are similar, therefore ratio of the corresponding side will be equal, right? So we have AO by OB is equals to OC by OD, that is AO by OC is equals to OB by OD. This becomes our proof. Okay students, proof becomes very easy. Just we need to prove they are similar, right? Okay, let us move on then. I shall erase it. So question number 4 then. Now question number 4 we will do. As you can see in question number 4, figure has been given, right? So we have our figure. Okay. Join this as well as join this. This is 2, right? That is 1. This is P, is S. So what is given? It is given that QR by QS is equals to QT by PR, and angle 1 is equals to angle 2. So what is need to prove? We need to prove that PQS, triangle PQS, similar triangle TQR. Clear? Triangle PQS, this triangle, and triangle TQR, this small triangle and big triangle, they are similar. So proof becomes very easy. You know how? See, from triangle PQR, what can you have at first? PQ is equal to PQ is equals to PR. Why? Because see, from triangle PQR, these two angles are same, so their opposite sides should be equal, right? So PQ is equals to PR. Why? Because angle 1 is equals to angle 2, right? and also it is given, and QR by QS it is equal to QT by PR. Now what we are doing is we are subtracting both side 1. So QR by QS minus 1 is equals to QT by PR minus 1, right? So why we are doing that? As you can see, if I am able to prove that QR minus QS by QS, see here, QT minus PR by PR. As you can see, QR minus QS will become SR. Clear? Will become SR. So that's our objective, to find the relationship between triangle PQS and triangle TQR. Okay? So QR minus QS is equals to QT minus PR. But as you can see, PR is equal to PQ. So in place of PR, we can write PQ. So QT minus PQ by PR. Clear? Okay. So as you can see, QT minus PQ is equal to PT, right? And QR minus QR minus QS becomes SR. So therefore here SR by QS is equals to PT by PQ, right? So what you have, just imagine SR, just reverse it. At first just reverse it. So we have QS by SR is equals to PQ by PT. Now see, QS by SR is equal to PQ by PT. So therefore PS divides QR and PT in the same ratio. So by proportionality theorem now we can apply proportionality theorem, right? What do you have? QS by SR is equal to PQ by PT, right? Therefore PS divides QR and QT in the same ratio. That is what it means. We can apply proportionality theorem. Hence, by proportionality theorem, what you have? We have PS parallel TR. Clear? PS parallel TR. Now this proof becomes very easy. So from triangle PQS, triangle TQR, what we have? Number 1, we have angle Q is equal to angle R. Number 2, we have angle P is equals to angle T. Why? Angle P is equal to angle T. As you can see, angle P is equals to angle T. Why? Because PS parallel TR. PS parallel TR. Right? So PQS and TQR, similar angle. See, they are parallel. This intersector. So this angle and that angle should be equal. So if you are not able to understand, there are quite a few angle P. So just write here angle Q is equals to, write in proper name. Okay. So we are going to write angle T. PQS and TQR. So we have angle TQS is equals to angle TRQ. Number 1. Number 2, we have what? Angle QPS is equals to angle QTRY. Since PS parallel, it just proved PS parallel TR. This becomes similar angle, then this angle becomes similar angle. Right? Since two of the angles are equal, therefore third angle should be equal. So we have angle PSQ is equals to angle here you just write before TRQ. Here you just both of the angle, both PQS and TQR both contains angle Q. So if you here write TQS and there you write TQR, angle Q is equal to angle Q, and now this angle should be equals to that angle. That means TRQ. So angle similarity. Therefore PQS similar triangle TQR. Why? Angle similarity. Okay, students, this completes our question number 4. Clear? Okay. I hope you understand this. Understood this. Okay. Let us erase this one then. Now question number 5. We have S and T are points on side PR and QR of triangle PQR. So there is a triangle PQR. PQR. We have S and T are points on PR. So PR is and PQT. Such that angle P is equal to angle RTS. Angle P is equal to angle RTS. This angle. So that RPQ similar RTS. RPQ RTS. So RPQ, this whole triangle should be similar to RTS. Okay. RPQ RTS. Angle P is equal to given angle RTS. SNTR points on the side PR and QR such that angle P is equal to angle RTS. We have to prove what? What is given? Given angle P is equals to angle RTS. S and T are points on the side PR and QR of triangle PQR such that angle P is equal to angle RTS. These two angles are equal. We have to prove, we have to show or prove that triangle RPQ, this big triangle should be similar triangle RTS. Okay. This is question number 5. Some data I think is missing here. Angle P is equal to angle RTS. This angle and that angle are equal. Angle P, that angle, RTS, this angle, these two angles are equal. If I redraw those figures, P, Q, R, if I join this, TSR, such a way, in such a way, suppose this one. Yes. So TSR, right? So I think it will be done, right? PQR, TSR. See, angle P is equals to angle T. Now we have redrawn the triangles. Then it becomes easy. Now why? First is given. So from triangle PQR and triangle RST, what do you have? Number one, you have angle QPR is equals to angle STR. Why? Because it is given. Okay. And number two, what do you have? Angle QRP is equal to angle SRT. Why? Because both are same angle. Same angle. Since two angles are equal, the third angle should be equal. So PQR is equals to angle TSR. Right? Don't write like that. Therefore, we must have. Right? Therefore, triangle PQR, similar triangle RST. Why? Angle, 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 similarity. Clear, students? So just it's a matter of perspective, right? Now it is given. Now let us continue and do our next question. Question number 6. Next question, which is question number 6. Question number 6 says figure 6.37. So there is a figure. We have A, this is B, this is C, join, becomes E, this becomes D. They've joined this. It is given that, what is given? It is given that triangle ABE congruent triangle ACD, right? ABE congruent triangle ACD. We have to prove that triangle ADE similar triangle ABC. So ABE and ACD, these are congruent given. So since triangle ABE congruent triangle ACD, what we have at first? Angle ABE is equals to angle ACD, number one, right? And we have AB equals to AC. right? Clear? This one, this one. Moreover, what can we have? Well, if I'm going to use this, which will be of no use, right? Which will be of no use. This will not be of any use. So since they are congruent, first can we, what can we say? Since these are congruent, we can say anything, right? But in order to prove ADE triangle congruent ABC, what we need to prove? We need to prove either AD by DB is equal to AE by EC, or we can prove the criteria. So ADE and ABC. First of all, our one angle, angle A, is common in both the triangles, right? ADE and ABC. We need to prove another triangle, another angle. So this and this, if you are able to prove, then this angle and this angle are equal, then a proof will be suffice. Now, how can you prove that? At first, let us see that since this triangle and that triangle are congruent, what can we say? We can say AE is equal to AD. See, this triangle and this triangle are congruent. So we will say AD equals to AE, right? Clear? AD is equals to AE. Okay? This triangle and that triangle. We are going to say AD is equals to AE. Again, since ADE, ABE congruent ADC, we can say AB is equals to AC. We can say AB equals to AC. Right? Now, since AB equal to AC, we can subtract same thing from both the side. So AB, I am subtracting AD both side. AC minus AD. Clear? Now, as you can see from equation 1, what can we say? In place of AD, we can put AE. So here I am keeping it AD, but there I am changing it to AE. As you can see, AB minus AD becomes BD. So BD equals to, therefore, AC minus AE becomes EC, right? So hence we have BD by EC is equals to 1. Also from 1, what can we say? AD by AE will also be equals to 1, right? So consequently, we can say what? This by this is equal to this by this. So we have AD by AE equals to, we have BD by EC. Clear? BD by EC. So hence just transform it to here. We can say AD by BD is equals to AE by EC, right? So corresponding sides are proportional. Therefore, hence, what can you say? ADE Triangle AD, similar triangle ABC. Clear? This becomes our proof. Okay, students. Then this is it for today. Okay. See you on the next class. Bye bye. Have a nice day. This is Srikanth Roy signing out.